I'm Stephen Foskett. Welcome to Tech Field Day, coming to you November 2016 from Silicon Valley. We're here with StorageOS and the delegates that we've brought in from around the world. These are folks who specialize in servers, storage, networking, and they are intending to be part of the discussion that you're about to see. If you'd like to learn more about Tech Field Day, come to techfieldday.com. And if you'd like to see more videos like this, just go to youtube.com/techfieldday.
Hi, so my name is Alex Chircop. I'm the CTO and founder of StorageOS. And in this section, we're going to talk about how we can use StorageOS in both hyperconverged and traditional client-server topologies. So what we discussed earlier is we can deploy StorageOS as a container running in any operating system that supports containers. So the more traditional way of deploying StorageOS is, in fact, in a so-called hyperconverged system, where you have a number of nodes, and the nodes each have an amount of available storage. And we have our StorageOS container running on each of those nodes. And that creates this pool of capacity that extends across each of those nodes. Through this pool, we can then carve out volumes. The volumes that we carve out are presented with a global namespace across every node in the cluster. So, if an application is accessing a volume, that volume also appears on all of the nodes within the cluster. And if the application moves to another node, the application continues to see the volumes, the snapshots, and any of the provisioned resources that were provided to that application. Now, however, there are many scenarios where perhaps you don't necessarily want to do a hyperconverged type solution. One is where you don't want to mix your maintenance windows or your operational controls across both compute and your storage environment, or perhaps where you want to optimize your deployed hardware for different use cases. So some users might want to have a compute environment which might be very dense, that doesn't actually have the ability to include a lot of storage, and might have a number of dedicated storage nodes that might have 16, 24, 48 disks or whatever. So one of the big advantages of StorageOS running as a container is if you have another node where you have your application, we can also run StorageOS on that node. And effectively what we're doing here is we are giving a client node a fully fledged control plane and data plane. So by virtue of the fact that it's got a control plane built into the node, it can now see pardon my drawing, it can now see all of the namespace and all of the volumes that are available on each of the StorageOS cluster nodes. And that means that the application can now move between any number of nodes, even if they're not part of the replicated StorageOS cluster. So we have, for example, a number of clients where they're using this exact use case, where they're dedicating 5 nodes, 7 nodes to the system to provide to provide storage capability. And then they might have a large compute cluster, perhaps on VMware, perhaps managed with OpenStack, where they need to have the ability to for the containers to get access to those different storage volumes. And it's a simple matter of just deploying our container in client mode, and effectively you extend that global namespace into any number of your client applications. There's also another side benefit. Because the client has a fully fledged data plane in there, the data plane also has the capability to implement all of the storage primitives and all of the data services that you get on a fully fledged server node. So you can now do interesting things like run a caching layer directly on the client. Or you can do things like offload your encryption or compression by doing your encryption and compression directly on the client. And remember, because it's a zero knowledge base encryption system, you can now encrypt data on your client using keys perhaps supplied by your application that your server environment doesn't know anything about. So your applications can run against the server environment that's perhaps less trusted or doesn't have the processing power to actually carry out the encryption at scale, and allow it to secure the data in a zero knowledge method such that only the application or only that client can decrypt and access the data. And remember, all of the decryption, encryption, data services, caching, replication, etc., all happen atomically to a volume. So the encryption keys, the data policy methods are all switches that you can apply to any volume in any manner, and different encryption keys can be used for each of the different volumes. And now one of the reasons, can you switch to this synthetic slide? One of the reasons where which we're really proud of is we've spent a lot of time. The web page with the synthetic benchmarks. The web page with the synthetic benchmark. So one of the things we've done is we've spent a lot of time optimizing each of the different modules in the data plane, whether they're compression or encryption or deduplication, to utilize all of the latest features in the processors, to utilize the acceleration features that are available in each of the processors. And we actually do lots of regression tests every time we make any tweak to the data plane or any time we develop or add a new module to make sure that none of those changes have affected any of the operation or any of the accelerations that we've sort of hand optimized in those systems. So effectively we can take advantage of all of the latest benefits of, say, the Intel processors, the 64-bit processors, and we can get amazing performance out of very commodity hardware. So, for example, when I mentioned things like compression and things like that, and encryption, we tend to measure them in millions of IOPS and gigabytes per second. And I know this sounds fairly ludicrous coming from certainly my previous background in storage systems. Thinking about a storage system that could do millions of IOPS or gigabytes per second was certainly going into the 7 and 8 figure numbers to buy them. But actually, processors nowadays are incredibly powerful, and with a little bit of hand tuning, these algorithms can be made exceptionally fast on traditional systems. So, as an example, that is just a 4-core, $500 commodity PC that we use as our test benchmark. And as you can see, we kind of test regressions and make sure that any changes are maintained across the different versions of our platform.